Hey guys, welcome back from winter break. Hopefully you guys had a great time off, were able to relax, enjoy everything, spend some time with family, maybe go and explore a little bit. Just a reminder, I will be out for the rest of this week, but I will be back next week, so I will see you guys on the 12th. Today we are going to run through graphing systems of linear inequalities. We've already talked how to graph inequalities. Now we're just going to look at the systems. Super easy, you're just putting two graphs on one coordinate plane and seeing where they overlap. So we'll go through that. Tomorrow you are going to have another video where you are looking at reviewing for the quarterly comprehensive, the quarter 2. They open the window into January, so I figured let's talk systems, make sure we're good, and then you guys can take the quarter 2 comprehensive. So we have graphing systems of linear inequalities today, the review tomorrow, and then we have the test Thursday and Friday. So you'll be able to take the test over the course of 2 days. I do believe it's 20 questions, anywhere between 20 and 25. Again, I need you to try your absolute best on this test, okay? Do not just blow it off. Don't think it's not going to count for anything. It is going to go into focus. It's going to be one of your first grades in there for quarter 3. So make sure that you are trying your best, and hopefully you will pay attention to the review, get some unanswered questions maybe. Don't forget, when you're taking the test, eliminate the answers that don't make sense if it's multiple choice. We've been practicing that in class. You guys have been doing a great job with identifying the incorrect answers, at least the ones that throw us, right? So just continue to practice that as you take your test. So without further ado, we're graphing systems of linear inequalities. So step 1, we're going to follow the same rules as regular inequalities, but we're going to plot and shade both lines on the same coordinate plane. Okay, so both lines are going on the coordinate plane. The solution set is the area where the shaded regions are going to overlap. We can check points algebraically if we want to check to see if we solved it correctly by substituting. You can always check an answer with substitution. So we can either substitute values into the inequality and simplify, and then if both statements are true, the point lies in the solution region. Okay, so just to review some of the graphing stuff, because it's been 2 weeks now since we've done it. If I am using a less than symbol or a greater than symbol, it is the same thing as using an open circle. Okay, when we are graphing on number lines, you guys were doing a great job with open circle versus closed circle. So just remember, if we're less than or greater than, that would be an open circle. Therefore, I need an open line, which would be our dashed line. And then our less than or equal to or greater than equal to, it takes that effort to draw that line and to fill in that circle. So if it's a closed circle, I need a closed line. Okay, so we have open symbols and closed symbols. Moving on to our first example, we are graphing. Again, when we are graphing, we want to make sure that we are written in slope-intercept form. If we're written in a different form, our first inequality, though, is x is less than or equal to -3. So that's just something that we need to go in and graph. So I'm going to go when x is -3. I have a line under my sign, so that means I'm going with a solid line. And again, this is when x is -3, so that means I need all of my x's to be -3. And then it says x is less than -3, so I want all the numbers less, and less is to the left. So we're going to shade in this region. everything to the left side of our line. Then moving on to our second line, we are in slope-intercept form, so we are good. We can go ahead and just plot our y-intercept, which is 2. Then I have a slope of 5/3, so that's telling me go up 5 and over to the right 3. I can only get 1 point to the right, so I'm going to go ahead and fill in my points to the left. And again, that would be reverse directions. Okay, so if I was up 5 to the right 3, I'm going to be down 5 to the left 3. We can kind of see the first intersection happening right there. And some overlap starting to happen into the blue, which is good. That overlap is where our solution lays. So we definitely want to see that overlap happening. Then we're going to look at our sign, and my sign is just a regular greater than sign, so I need to make sure that I am using dashed lines. Doing my best to kind of keep that line straight, but it's whatever, you know? We're not computers. Alright, now I need to look for my graphing. So my sign says that y is greater than 2. I'm currently at 2. I need all my y's greater than 2, which would be in this direction, which means I need to shade all of the region that is up over my line. So I'm going to come over here. I'm going to start shading. I'm going to shade in an opposite direction than I shaded before, just to kind of better see that overlap. I know I'm using 2 different colors, but the direction also kind of helps. Alright, so then we can see our overlap happening within this region right here. We can kind of see where this area is just blue, so it's just the solution to the first inequality, and this area is just red, so it's just the solution to the second inequality, but then a solution to both is living right here in this shaded region. Okay, sometimes there are computer systems or programs that would then ask you to erase any of the single solutions and only give the shaded region. So you can do that. I'm not saying you have to, but I'm just going to show it to you guys. That way you can also see the overlap a little bit better. Sometimes they don't even give you the option to erase it though, and you just need to put your lines down first and then shade after to be able to get that overlap, which I can do on the second problem for us. Okay, so moving on to example 2. We see that we are not written in slope-intercept form. We're written in, yep, that's right, standard form. Okay, so 4x plus y is less than 2. I need to solve for my y by subtracting 4x. So y is less than negative 4x plus 2. And then my second equation, I am written in slope-intercept form, so I am fine. Also remember, all I did was subtract by the 4. That's why it became a negative 4x. There was no multiplying or dividing, so I do not need to flip my inequality sign. Alright, so let's go ahead and graph our first one. We have a y-intercept of 2, so we're going to start there. And then we have a slope of negative 4, so we're going to go down 4 and over 1. And to fill in the left side of my line, I need to go opposite directions. So instead of going down 4 right 1, I need to go up 4 left 1. And let's go ahead and put our line down. I see that I am just a less than sign, so that means I'm going to use a dashed line. And get my arrows on there to show that I continue on. And I'm not going to shade yet. I'm going to wait to shade after I graph both. That way we can kind of find that overlap and only shade in the overlap. So starting with line number 2, I'm looking at -2 as my y-intercept. Then my slope is 1/2, so I'm going to rise 1, run 2. So up 1, right 2. And to get the left side, I reverse my direction, so down 1, left 2. Okay, that is a greater than or equal to sign, so I need to make sure that I am using a solid line. Arrows on both ends to show that my line keeps going. And now we'll look at graphing. So I just want to graph the overlap, which means I need to pay attention to what direction I would be graphing for each line and kind of see where the overlap is going to take place. So if I look at my blue line, it says that y is greater than 2. So this is my 2. And I need all my y's greater. So if I want all my y's greater than 2, I'm sorry, that's not greater, that's less than. For a second there I was like, wait a second. I need all my y's less than 2. Let's try that again. I hope you guys just caught that. All my y's less than 2. So we're going to go down below the line. So this is going to be my whole blue shaded region. Okay, so this whole area would be blue. Then looking at my y is greater than -2. So I would be shading for my red line this whole region up here. So I want this area shaded in for blue, this area shaded in for red, which means the overlap is happening right here. So that's where I'm going to go ahead and fill in my overlap. And that is my shaded region. Moving on to constraints. We see constraints when we're working with word problems. Okay, remember word problems are real world examples. So I need to make sure that I'm putting limits on things, I'm putting restrictions on things. That way or all my numbers, not things. That way it makes sense. Okay, because eventually there's going to be a minimum to something, a maximum to something, so we want to make sure that we're using those constraints. Sorry. So in math, constraints are restrictions. That limit what is possible or what is reasonable. In a real world situation. So if you guys think back to like the Unit 4 test about that car wash problem where it was that they could buy 20 car washes and we had to talk about the domain or the range, it was asking one of the two. And we were like, well, you know, the minimum number of car washes they can have is 0 and the maximum is 20, and then we had to pick the best answer. Those would be those constraints, right? Because the answer was saying, oh, it needs to be that washes are greater than or equal to 0, and it's like, okay, well that's not true because we can only have 20 car washes. So the constraint that you would really look at would be, you know, the car washes could be between 0 and 20, It could be 0, it could be 20, but they weren't giving that as an answer, so we had to pick the best answer. But again, those are an example of like the constraints that we would see in math in a real world problem. So looking at example number 1, we have Xander is organizing his crock charms. He has X animal themed charms and Y food themed charms. He has at least 7 of each. So we have some keywords, at least 7 of each, but all together he has more than 35 charms. Okay, all together is my buzzword that tells me I should be adding. So if I'm looking to add, I have animal, which is X, food, which is Y, so I have X plus Y. Then it's saying it's more than 35. So we need to be greater than 35. So that's going to be our first answer there. We can eliminate this answer because it says or equal to. And then we have at least 7 of each. That means I can have 7, but that's the bare minimum. So I could probably have more than 7. And it says of each, so the same thing is going for Y. So we're going to go ahead and pick B and D as well, and cross out the other answers because those guys were saying, oh, we're just greater than 7. And on to example 2. Michelle is studying for her fast reading and algebra exams. She decides she wants to spend more time studying algebra than reading. Y'all should learn from Michelle. Just kidding, I didn't say that. More time studying algebra than reading. Altogether, she wants to spend more than 8 hours studying for both exams. Okay, maybe you should be like Michelle. You should definitely be like Michelle. Alright, let's compare. So if she wants to spend more time studying algebra than reading, we're going to go ahead and use A for algebra, R for reading, keeping it very original here. We can go ahead and do that first comparison where algebra is going to be greater than reading because we want more algebra than we do reading. And then we're looking at adding because, again, that buzzword altogether. So we're saying A plus R is more than 8, so we're going to be greater than 8. Alright, and that wraps us up for us. So that is graphing systems of equations, or graphing systems of linear inequalities. So you guys are now going to move in. If you've got some leftover time, go ahead and work on your homework. It is posted for you in EDIA. You also have topical number 10 that you can be working on. That opened up today. So go ahead and spend your rest of your time working on that. Please, please, please make sure that you're on your best behavior for your guest teacher for the rest of the week. Do not ruin my Hawaii trip because of your behavior. Just kidding. I'll show you guys pictures when I get back. I'll tell you all about it. And I will see you guys in a few days.